Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to be doing another question for the grade 11 related to electrostatic, which is a very important topic. It can have a lot of marks in the exam. So subscribe to the channel so you can get all the notifications and videos I post on regular basis. Well, this one was question 5 done in the Gauteng province in 2023, and it's a good question. So let's go to the question. The question says a small metal sphere P is placed on isolated stand. The sphere carries a charge of -4 nanocoulombs. Let's speak about the conversion quickly, these units, and then you're going to have two main units that can be given to you and you have to convert. Those are the nanocoulomb and the microcoulomb. Those are the main ones, and you need to know that this one is equivalent to 10 to the -9 for the nanocoulombs, and the other one is times 10 to the -6. So all you have to do is to multiply by each of these one to convert to coulomb. It's quite important. I think I should highlight this kind of sticker, if I may say, and then that is an important note for later on, as well as for the specific question we are going to do. The question says, state the principle of conservation of charge. And it's an important principle. Is in grade 10, or it was done in grade 10, and you are going to use it most of the time. So let's write it at this specific point, 6.1. The total, or the net charge, you must fix that word, the net charge in an isolated system is constant. During any, that is any, let's fix that, any physical process. Right, that is the conservation of charge. Guys, it's going to be asked, it could be asked in the exam for grade 11, for grade 10, 100% sure it is going to be asked. There is 2 marks for this one. However, there are important factors here. One of them is net charge. If the word net is another, you won't get the marks. And then isolated system. If the system is not isolated, this also won't happen. That is why this charge or this sphere is on an isolated stand. So the charge don't move from the sphere to the ground. That is the purpose of that isolated stand. Calculate the number of electrons in excess on sphere P. So sphere P is negative. That negative here means that I have, and let me just write it down here, this negative there, it means that I have more electrons. It have more electrons than protons. In other words, they have an excess of electrons. It have an extra electrons, a number of extra electrons in here. Now, what is this? This is charge quantization. It's also done in grade 10. So what data do we have that we can use here? And let's write the data on this side here. Data. First of all, we have the charge, which is equal to -4 times 10 to the -9 coulombs. Remember, you have to convert. We have the charge of 1 electron, which is given to you. It is a constant and is in a table at the end of the exam. It's -1,6 times 10 to the -19 coulomb. It's given to you there. And then you're looking for the number of electrons. That is the question mark. Guys, there is a formula also that is going to be given to you. Number of electrons is equal to the charge, or the number of electrons or elementary particles, it could be protons as well, is equal to charge divided by the charge of 1 electron. This one is how to calculate the number of electrons that this specific sphere have in excess. So the number of electrons, if you substitute, is -4 times 10 to the -9 divided by -1,6 times 10 to the -19. This one will give you the number of electrons. So let me use my calculator real fast, guys. I have it here at the front. 4 times 10 to the -9 divided by 1,6 times 10 to the -19. This one will be 2,5 times 10 to the 10 electrons. It means it have that number of electrons in excess. That is the answer. Guys, 3 marks is quite simple. 1 for the formula, 1 for this substitution, 1 for the calculation. This one is how to calculate the number of electrons that a sphere or an object have in excess. Note something important. That number of electrons must be positive. So the final answer must be positive there. The next question says a second identical metal sphere Q carrying a charge of positive 3 times 10 positive 3 nanocoulomb. Remember, you have to convert. I think we can convert some here. This charge is positive 3 times 10 to the minus 9 coulomb. Is placed 4 centimeters. You cannot work in centimeters. We are going to convert from centimeters to meters. You divide by 100. So this one is divided by 100, and this one is 0.04 meters. That is the conversion here, as shown in the diagram below. And you have the diagram below. You have a negative charge, you have a positive charge. They don't speak here in this question about drawing, but we are going to quickly draw the attraction here, the electric field, using field lines, because it could be asked. So for that one, let's use another color that we don't have. Maybe we can use this brown one here. So always the lines going from positive to negative. So it will be lines going in this direction. Then these lines are going to turn in that direction like this. Then it's going in this direction. Remember, those lines cannot touch each other and they turn towards. So there is more lines here that is going in that direction from positive to negative, and then those lines eventually will come back here to this point. There are certain rules to draw. It's not the purpose of the question, but I want to show you because I see mistakes. Now, on the other side of the sphere, also, guys, you need to draw lines like this one. For instance, this one is going all the way out, which eventually will go all the way and reach that sphere P. Now, something important I'm going to mention here, and is the size of the charge. For instance, a P have a greater charge, not because it's negative, but because it's 4. 4 nanocoulomb is greater than 3 nanocoulomb. The minus and the plus just have to do with the number of electrons that it has in excess or in deficit. So in this case, that 4 is greater than 3, P is greater than Q in terms of the size of the charge, the magnitude, so it should be more lines drawing. I just want to draw it there. So I just draw one extra line. So this one is how it will look, those two spheres. All right, now question 6.3, state Coulomb's law in what? Guys, Coulomb's law, it is going to be asked in the exam. It is always there, it's always been there, and the formula for Coulomb's law can tell you that specific law. So let's write the law here at the bottom. That one is question 6.3. 6.3. So let's have a look, question 6.3. Now, Coulomb's law, the formula is this one, K, Q1, Q2, divided by distance. I'm going to write distance squared. You can either use distance. That distance doesn't mean radius, it means the distance. All right, and then this one is Coulomb's law. Guys, from here you can write the law. The law states that the electrostatic force between two charges is directly proportional to the product of the charges. That one is coming from here. It's coming from here. The force is directly proportional to Q1 times Q2. So the electrostatic force is directly, let me fix this one, proportional to the product of the charges. That is the first part of the law, which is written in this specific point there, guys. This one is the first part of the law. The second part of the law, also coming from the formula, the second part of the law, we can write it down here. F is inversely proportional to the square of the distance, as you can see there. That is the second part of the law. It is coming from the formula. So all you have to do is to be able to write it. The electrostatic force, if you write it all in one sentence, you can say and the electrostatic force is inversely proportional to the distance squared, or to the square of the distance between them. That one is the second part of the law. You'll get 1 mark for each of those specific sentence there. Guys, is coming from the formula. All you have to do is to be able to read in terms of proportionality and relationship between force and product of charge, force and a square of the distance. Now, question 6.4 say, is the force that P exerts on sphere Q a force of attraction or repulsion? Well, they are unlike charges. Unlike charges attract each other. You can see them there. So the answer here is attraction. They are attraction. That is the nature of the force. When they speak about the nature of the force, is either attracting or repulsive. That is the nature of the force. The spheres are now brought into contact with each other and then return to the original position. So in other words, the spheres are coming together. That is question 6.5, and they are separated. 6.5. So what is going to happen? The two spheres are coming in such a way that they touch each other. Now, when that happens, and let's go, because I don't remember, it's P and Q. There we go. P is on this side, Q is on this side. Now, P, if we go back, and I want to write this one, is negative 2 nanocoulomb. So P is negative 4 nanocoulomb. You don't have to convert for this part of the work, and positive 3 nanocoulomb. This one is positive 3 nanocoulomb. Guys, what is going to happen, and this is the physical process we're speaking about for the law or principle of conservation of charge. Electrons are going to move from one sphere to the other. In this case, they're going to move from P to Q. So electrons are going to move Why from P to Q? From the more negative to the more positive. I'm going to write from more negative to more positive. All right, so that is important to know. The electrons are going to move always from the more negative side to the more positive side. So eventually, when they are separated, they got a new charge. And that is what the question is asking about, that new charge. So what you're going to say, Q new is equal to charge P plus charge Q divided by 2, because there are only two spheres related here. For this question, or for this formula, you do not have to convert. In other words, we can have that is minus 4 plus 3, because it's positive, divided by 2. All right, so we have negative 4 minus 3, that is negative 1 divided by 2. So you have a negative half nanocoulomb. In other words, this is equal to negative 0.5 nanocoulomb. I work in nanocoulomb. So in this case, you don't have to convert. At least the question said do it in coulomb. They say calculate the new charge on each sphere, and this is the calculation. Guys, they generally don't give mark for the formula, but I highly advise you to write it, because you don't know if they are going to give mark for the exam, for the formula. So in this case, it's 1 for the substitution, 1 for the final answer there. So it's a negative charge. Each of them will have a negative charge of 0.5 nanocoulomb. The next question says calculate the magnitude of the electrostatic force now exerted by sphere P on Q. Now, there is a repulsive force here, because both of them will be negative 0.5 nanocoulomb. So they are going to be repulsive. And we're going to speak about that one in terms of the direction of the force. Let's calculate first the magnitude. This one is question 6.6. To calculate the magnitude, and note they ask to calculate the magnitude of the electrostatic force, no direction, but we're going to speak about direction as well. So to calculate the magnitude, all you are going to do is to use Coulomb's law. So Coulomb's law is going to be F is going to be equal to K times Q P. You can use Q1 if you want. So QP, Q divided by the distance square. That is the one. And then the formula is given to you, the constant is given to you. So all the rest is just substitution, guys. So now we substitute. F is equal to K is 9 times 10 to the 9 times QP. Remember, this is after they touching, after they've been separated. So each sphere will have a negative 0.5. Note, do not substitute the signs in this formula. So this one is 0.5 multiplied by 0.5. You cannot, and you have to convert. Remember, you have to convert to coulombs. I was not going to convert. I want to convert here. This one is equal to negative 0.5 times 10 to the minus 9 Coulomb. I'm converting. All right, guys, you don't have to convert there if you don't want to. But for the calculation using Coulomb's law, you must convert. So this one is 0.5 times 10 to the minus 9 times 0.5 times 10 to the minus 9. Remember, do not substitute the signs in this formula. You cannot put the minus in here. So now when you come here, the distance is 4 centimeters. They were moved back to the same place as before, so it's 0.04 square. Do not forget the square. Also, some learners attempt to forget that square there. So when you calculate, I'm going to use my calculator. This one may be a little bit long calculation. Times 0.5 times 10 to the minus 9 times 0.5 times 10 to the minus 9 divided by 0.04 square. You'll get that the answer is, and I need it in scientific notation, guys. Make sure you also move your calculator to scientific notation. So you will get that the force is going to be equal to 1.41 times 10 to the minus 6 Newton. It's a very small force between those two spheres. The charges are quite small. All right, so that is the force between the spheres. Now, the question is up until here. They ask you to calculate the magnitude, which is that one there. There's one, let me see, the marks allocated in this question is 4. So it's one mark for the numerator, one for the denominator, one for the final answer. But I want to mention something. The question say that is the force P on Q. So P on Q, and if we go here before we even move, now remember you have P, you have Q. Those charges are both negative because that is after they separate each other. So they're going to repel. P on Q is going to be pushing Q to the right. This one is F, P on Q. And Q is pushing P to the left. This one here is force Q on P. And this one is a action-reaction pair. So you need to know that F PQ is equal in magnitude opposite in direction to, let me erase that line there, to F QP. They are equal in magnitude, opposite in direction. The question asked for P on Q, so it's to the right if the direction was asked, but was not the case. This is repelling forces. Now, question 6.7, by what factor will the magnitude of the force in question 6.6 change if the distance between the spheres is now half? Now, you do not have to calculate, and guys, this question is always there. This question is always there. So now, the force that we're dealing with is, let's call, and let me just write, this is question 6.7. This is always there, and it's in the multiple choice you will get things like this as well. This is question 6.7. So now you have that the force is equal to K QP QQ divided by distance squared. Now they change and they make the distance half. All right, so F is equal to K QP. Write the P here. QQ divided by distance squared. But distance is half the distance. All this one squared. All right. So I hope you are with me here. Now we have to solve this one. F is equal to K QP. I keep writing a capital. You can write either capital letter or small letter. It doesn't really matter. Q divided by, when you solve this one, this is 1/4 of R squared. That is when you solve that specific square part there. All right, so now if you solve this one is simple math, you get that F is equal to K QP QQ divided by distance squared multiplied by 4/1. All right, so guys, F will be now 4 times K QP QQ divided by distance squared. This one, look here, is that one there. In other words, it will be equal to 4 times the force, let's say, before. That is the answer, will be 4 times bigger. Guys, this is how to approach this question. I hope it helped. It's a good question to practice. It's not that of a challenge, but this is a good question. We have most of the aspect. Thank you for watching. If it helped, thumb up, subscribe for the channel, and then I'll see you next time. Mr. G.